Hi.
Hey everyone, welcome to Python Code Nemesis. Today we'll be understanding Event Bus Python messaging service. An event bus is a messaging system that enables communication between different software components or services within a more extensive system. It allows these components to communicate by sending and receiving messages or events through a central hub or bus. An event bus typically operates on a publish-subscribe model, where a publisher component sends an event to the event bus without knowing which other components are interested in receiving that event. Any number of subscriber components can then receive the event from the event bus and perform some action based on the contents of that event. The event bus is a critical component of many distributed systems as it allows for loose coupling between different components and enables them to communicate without knowing specific details about each other. This makes it easier to develop, test, and maintain complex software systems, as changes to one component are less likely to break other components that depend on it. Event bus Python. In Python, an event bus can be implemented using various libraries or frameworks that support message passing and event-driven programming. One popular library for implementing an event bus in Python is the PyEventEmitter library, which provides an event emitter that can be used to publish and subscribe to events. Here's an example. From PyEventEmitter, import event emitter, create an event emitter, define an event handler function. So what is an event handler? In the context of an event bus, an event handler is a function or method registered with the event bus to handle specific events emitted by the system. When an event is emitted, the event bus notifies the appropriate event handlers registered to handle that event. These event handlers are responsible for performing some action or executing some code in response to the event. The actions taken by the event handlers may depend on the data passed along with the event, as well as the current state of the system. So here we have an event emitter. We have defined an event handler function, which is handle event, which gets in some data, and then it prints receives event with data and the data. So here the event emitter dot on my event, comma handle event is making this event emitter subscribe to the my event event. And when this event happens, this event handler is supposed to be executed in response to this my event event. Now to test this, publish an event with some data. So eu.emit, where the first argument is the name of the event, and the next is the data that is passed in, which is message, and the text is hello world. So this will be printed as data. We already went through the code explanation. So this was just an example of how the library can implement an event bus in Python. Other libraries and frameworks such as async.io or Flask SSE can also be used to implement event-driven systems in Python. Async.io is a popular Python library to write asynchronous code allowing non-blocking I/O operations in concurrency. It enables developers to write efficient and scalable code by allowing multiple tasks to run concurrently without blocking the execution of other tasks. What is an event loop? In programming, an event loop is a mechanism that allows an application to handle events and tasks in an asynchronous and non-blocking way. An event loop processes events and tasks continuously, checking for new events and tasks and handling them as they become available. The event loop in Python is typically associated with asynchronous programming frameworks like async.io. The event loop in async.io is responsible for scheduling and executing coroutines and callbacks in response to events such as I/O events or timers. So a coroutine is an asynchronous function. An event loop is responsible for scheduling and executing asynchronous functions and callbacks in response to events such as I/O events or timers. When an event was detected, the event loop queues the corresponding coroutine or callback to be executed in the future. The event loop then processes other events or tasks while waiting for the queued coroutine or callback to be ready for execution. The event loop is essential for asynchronous programming as it allows developers to write efficient and scalable code that can handle multiple tasks and events simultaneously. Using an event loop, applications can avoid blocking I/O operations and ensure that application remains responsive and available to handle new requests and errors. Async functions. In async.io, an async function is a coroutine function defined using the async def syntax. Async functions can use the await keyword to wait for the completion of other coroutines or I/O operations without blocking the execution of the event loop. Right. Event bus. In async.io, an event bus is represented by an event loop, which manages the scheduling and execution of coroutines and callbacks. When an event occurs, the event loop schedules the appropriate coroutine or callback to be executed in response to the event. Here's an example of how an event bus might be used in async.io to handle network connections. So in this example that we have, we define a coroutine handle connection responsible for handling incoming network connections. So we have a coroutine handle connection, which is supposed to be taking an incoming network connection. So there's a reader and a writer, and there's a while loop, which is always true unless there's a break. So it reads incoming data from the client. If the client has closed the connection, then exit the loop. So if not, then convert the incoming data from the client to string format, data.decode.strip, print the received message, echo the response back to the client, writer.write response.encode, and then await writer.drain. Wait until all the data is written to this socket. Right. Next, we define a coroutine start server that uses a function to set up the network server and listens for incoming connections. We use the async with statement to understand that the server is appropriately cleaned up when closed. So, async def start server, which starts the server. Server equal to await async io.start server handle connection localhost 888. So, does this create a loop? Does it call itself inside itself? Yeah, it does. So, create a new server and bind it to the localhost on port 888. Start the server in a context so that it's automatically closed when the async with block exists. So, async with server, keep the server running forever indefinitely. Await async.serve forever. Right. So this will be running forever. So as long as the server is there, so as long as the start server handle connection has some data, like if there is a connection from the client, it exists. If there is no connection, then it breaks from here. And then it breaks here. And then the server is not, it's none, so it will not run. So that will exit. Great. Next, we define another coroutine, send message, that establishes a network connection to the server and sends a message. The send message coroutine then waits for a response from the server and prints it out to the console. So async def send message sends a message to the server. It opens a connection to localhost on port 8888. There's a reader and a writer. Await async io.open connection, localhost 8888. So there's a connection with a reader and a writer. Create a message to send to the server, which is hello world. You can change it to, let's say, Python code Nemesis. Write the message to the socket. So writer.write message.encode. Wait until all data is written to the socket with await writer.drain. Read the response from the server. Response await reader.readline. Print the received response. And that's it. So finally, in the main coroutine, we create tasks for both start server and send message coroutines, and then use async io.sleep to wait for 1 second before exiting. So there's the main function which runs the async io event loop. Start the server and send the message to it, async io.create task, start server, async io.create task, send message. Wait for 1 second to give the task the time to run. Await async io.sleep of 1. And then run the main function in the async io event loop. So async io.run main. This is the main syntax. So create task and then run. So we arrive at the conclusion. So an event bus provides a way to decouple different components or services within a system, making it easier to develop, test, and maintain complex software systems. Changes to one component are very less likely to break other components that depend on it. So that's it for this article. If you found it interesting, then definitely subscribe and like this video. Thanks for watching. Happy coding.